Okay, welcome everybody to the last session today. With us is Christian Ottermann from 52 North, and GeoNode is a research data infrastructure.
Yes, I'm Christian Ottermann from 52 North, as Ben said. I'm a software engineer. Geoinformatics is what I studied, and I'm a software engineer and software, and consultant at 52 North. And we are doing a lot of projects with GeoNode and GeoNode as a research data infrastructure or part of a research data infrastructure. And I wanted to, showcase that today, or show you what GeoNode does, what it not does, and what it's capable to do. For this, we will just have a short look on what research data infrastructures are actually and what they, trying to achieve. Then we have a look at GeoNode, its architecture, its feature set, and then a hands-on. Originally, I was planning that you can access my laptop and access this my GeoNode instance. Unfortunately, the Wi-Fi doesn't allow that. So this will be just a demo, and I will click through it. Sorry for that. And after that, we'll have a little summary and have a look what research data infrastructure features GeoNode supports. So research data infrastructures, why and what is it? So research data is really of inestimable value because it empowers research, it offers new perspectives and advances knowledge. And it's most often not accessible to everybody. So if somebody does research and uses data, it's more common now, but in the past it was not that common to also publish the data in a raw format, to distribute the data, to make it accessible and so on. But to really, have research results that are reusable, we have to be transparent and the data has to be reproducible. So we need access to the raw data. And by this, we will achieve more research because we can reuse more data. Currently, there are kind of problems for research data. The data is stored decentrally. So if a researcher shares this data, it's on its private server, on the server of the university, server of the research institute or whatever. Most often only temporarily stored. I don't think you will find research data from 10 years ago, at least not the most of them. Most of them don't have standardized metadata. For example, the dataset Etzer showed us in the last presentation. He said you have to go to the original documentation of this dataset to have an idea about what column does what. And this is a solution that can be solved as there are standardized metadata formats to describe this. Research data is also often from varied quality, most often not documented what quality it is. And most often we don't have processes to assess what quality it is. And these are the problems research data infrastructures try to solve by systematically manage scientific and research data and provide a long-term archive or long-term storage of this and make it accessible through open standards. And by this also create a network that is both nationally and internationally, so that we can share research data across borders, basically. For this, it's very important to follow these FAIR principles. I'm not sure if you're familiar with FAIR principles, if they are already done in another session. That's why we are having a short look at that. So the FAIR principles are basically that data should be findable, accessible, interoperable, and reusable. Sounds a little bit duplicated. So if it's findable, maybe it's not accessible because we just found it, but it's find a password or something like that. Or the way we have to access it is really custom because somebody developed an API where we can download it or something like that. Or maybe it's even a web form where we have to supply our intent that we want to use it, and so on. These are all things that are not fair. But let's look at the details of the FAIR principles. So findable requires that there's metadata that has a unique identifier, a global unique identifier. For the most part, that this will be DOIs, but even a permanent URL would work. Data is described with rich metadata, and not just README beside that, but really rich metadata. And metadata is clearly and explicitly include the identifier of the data they describe. So we can share the metadata, and you can go back to the origin of this data. And it should be indexed and searchable, which is very important. So if you're exploring the world and trying to find a specific data set, somebody uses Google, and Google does something with data sets. So there are Google data sets or Google dataset search, but this is in the beginning. But yeah, you have to find it. Accessible means that we want to retrieve it in a standardized way. So you may share your data on an FTP server and in some kind of document structure, but nobody understands that. This is not really, accessible. Or you share your data in a data format that nobody uses, then nobody will use it. So we need a protocol to access the data, and we need a protocol that is standardized, a protocol that everybody understands. Also, it should support authentication, authorization. Maybe you have embargoed data or data that you don't want to share with everybody, but just a specific group. This should be supported by this protocol. And the metadata should be accessible even when the data are no longer available. I don't explicitly know why that's the case, to be honest. For me, the data should be available forever, but maybe you can just find it and then ask for the data, but by that it's not really accessible. So this is kind of a contradiction for me. Ask the PAIR principle authors about this point. So interoperable, I already used that word. We want to use, it's on the one hand on the access way. So we want to access the data in an interoperable way. And we want also to access the metadata in an interoperable way. So we want to describe data with a standardized set of languages. And we want to also we want also the data in a standardized way, not some custom CSV format, not some, some binary file that nobody understands except for the manufacturer of the sensor. We want really standardized data formats that we are able to parse and to understand. Etzer made the example with the shapefile, which is not really a standardized ESRI, just thought we create a data format, never standardized it, never described it really in detail. It was reverse engineered. So this is not interoperable. We should use vocabularies. For example, if you have a time series of temperature values, you don't want to say this is temperature with words, but you want to use vocabularies that give this word a semantic meaning. And we should, cross-references metadata. So if you find a data set that is interesting for you, this data set may link to other data sets that are similar or that have the same topic but a different time range or something like that. And last but not least, all this leads us to reusable. And for data to be reusable, it has to be, the quality of the data has to be described. If you go to some domains, if the data is not quality controlled or wasn't quality controlled, they are not able to use it. And if you don't state that it was quality controlled or how it was quality controlled, they won't be able to use it. And this, of course, also should be stated in a standardized way. We will have a look at some ways to describe that, but for the most part, most people ignore this. Exactly, we should state the provenance. So if you create a data set from another data set, you should state that where this original data came from. And of course, we should meet immunity standards for the domain we are working in. So for example, if you have meteorological data, you of course don't follow the marine standards, but you use the meteorology vocabularies or formats. Now let's have a look at GeoNode and have a look what of all these requirements GeoNode can fulfill. But first, let's have a look what GeoNode actually is. GeoNode is it describes itself as a geospatial content management system. So if you're familiar with CMSs like WordPress or something like that, you can curate content. And in this case, the content is geospatial enabled, so has coordinates or is a raster or something like that. But in the quintessence, we want to manage these data sets, and we want to publicate it, and we want to enable a discovery of these data sets. It's an open source project under the GPL. Uses a lot of other open source components that are also freely available. It's an OSGeo project. I'm sure you're familiar with that, or used software from the OSGeo project. And it's actually quite old, which was kind of surprising for me because I didn't know that. It started in September 2009, which is really, really old. And is currently available in version 4, which is roughly a month old. And we won't use version 4 today, but the older version 3.2, just because I know what's wrong in that version, and I don't know what's wrong in the 4.0 version. And I didn't want to have any surprises today. What does GeoNode does? We can upload and manage raster and vector data in various formats. For example, shapefiles, geopackages, geotiffs, KML, GeoJSON, anything. It allows us to curate the metadata of this for these data sets in a standardized format. In this case, we are using ISO 1915. You may be familiar with that. It's an ISO standard or UGC/ISO standard to describe geospatial services or geospatial data sets. But we are also using other standards, and we can also request metadata in other formats like Dublin Core, which is also quite adopted. We can also manage metadata of externally hosted data. So GeoNode is able to host data, to serve data, but we can also describe data that is hosted elsewhere. So if you have jumped somewhere, a GeoServer instance with some layers, you can just link that in this GeoNode instance and describe these data sets. It has user group management, of course, so you can restrict access to data sets, you can restrict access to specific groups of users or to the public or only to the specific user group and so on. And you can create maps, you can create content, so to say, based on these data sets. These are basically two parts that can be done. We can create maps, which is just a composition of different layers of some widgets with some diagrams, maybe some text or something like that. And you can create geo stories, which are kind of editorial content intermixed with maps or with layers that are displayed. So you can really you can really describe what this data does. You can show the data, then you can show a graph or something like that, and describe in detail what your work is about. And of course, it has some WebGIS functionalities, not that extensive. So if you're used to QGIS or ArcGIS on the desktop, you will be really disappointed. But it allows to subset data, to edit features, have some feature table to edit them. You can edit styles, so the styling, how the layer is presented can be changed, can have diagrams and so on and so on. But we'll show that. Now have a look at the architecture. So this is basically GeoNode. GeoNode is it consists of multiple components. The core of GeoNode is basically a Django application we see in the center. Django is a Python framework for web development, and it uses a custom UI with a WebGIS component called MapStore. MapStore is also a OSGeo project, and you can deploy it separately, but it's also baked in the UI of this Django application. And besides that, it uses GeoServer, also it was Geo project, and also basically maintained by the same maintainers. GeoServer is a data server, and all this functionality that GeoServer offers is integrated into this whole concept. And between that, some components for let's say fitting all this together. So we have an engine X for serving data, for serving static content. We have a celery for asynchronous tasks, for repeated tasks, and so on. We have a RabbitMQ to communicate between these components, some caching with memcache or GeoWebCache. And we have in this Django implication also an embedded PyCSW. I'm not sure how familiar you are with OGC services. Is there somebody who doesn't know what a CSW is? Great. Oh, okay.
I don't know.
Okay, then we will have a talk about that later. And this, yeah, of course, we have a component where we store the data. We have a Postgres database where we store all this metadata stuff, the Django data, so user data and so on, and also the vector data sets that are uploaded to GeoNode. Raster data is unfortunately only stored on the file system. So if you upload a geotip, it will somehow end in a volume if you're using Docker or on the file system of your PC. And that's also where documents that you upload to GeoNode will land. Documents, and didn't mention that before, you can not only upload geospatial data, but you can basically upload every file you want. GeoNode won't understand what they are. It can't preview them or something like that. So if you upload a PDF, it won't show you a preview window. But these are just plain files that are stored elsewhere and yeah, can be downloaded, and that's it. But also they can be described with standardized metadata. So if you have a file format that is not geospatial, or if you have a file format that is not supported, you can still publish it and make it available in an interoperable way. Let's have a look at, well, how does that look like? Yeah, originally I was planning that you can play with my GeoNode instance. It doesn't work, but let me show you how GeoNode works. Here we have a Docker Compose setup of GeoNode. We are also deployed it in Kubernetes, and you can also run it directly on your machine. Here we have a Docker Compose setup that is kind of customized with some features that are not really in the plain GeoNode. And you can read that. Is it too small, or is it okay? It's okay. Okay. Here we see all these components. So we have a celery container, the database, Django, memcache, nginx, RabbitMQ, and so on. In this instance, we also have an Elastic stack. So we have an Elastic file build and Kibana running to store logs and to store monitoring data. You can do that. So there are really many optional ways where you can extend GeoNode, but we will just ignore these. And of course, we have a GeoServer. After this gigantic Docker Compose file is started, you can access GeoNode on your local browser. This is running on localhost. This is how it does look like in the raw variant. So we have no data in it yet. Just a landing page where we can see on the glance which data is there, how much data is there. You can also add featured data that you want to present really in the foreground. Move this. Oh, it's working this way. Here, I can. So I'm not muted anymore, I think. Is it working again?
Yes.
Okay.
Are you screen sharing?
Yes.
Okay. So this is the basic view of where you can edit data and upload data. You can also, of course, edit the style. If you click here, you get a quick glance of the WebGIS functionalities. So you can edit a style by just clicking here. In this case, it's unfortunately an uploaded style. That's why you can just edit the XML directly, but you can also create new styles, for example, based on SLDs, give it a name. Oop. Come on. And then you can choose channels and get a UI for how to visualize the data. You can also create different rules. We can see that late. Okay. You can create all kinds of styles with this. You can also select which channel should be the red one, green one, blue one, and so on and so on. But now we want to create a map, and for this we want to upload a few layers more, which are related. So we have here administrative boundaries, 2 shapefiles, and a GeoJSON file. And we just want to add them to GeoNode. So you can upload multiple layers at once. It's kind of nice. And after that we see. Yeah, while it's working, you can also describe who can access it. So in this case, if you're not logged in, you won't see it. But if you click here, it's a public data set. You can choose what's the group name? Registered members is the group name. You can assign it to specific groups. You can say who can download it, who can change the metadata, who can edit the data of this layer, who can change styles, and who is able to manage these permissions. These can assign to different people. As we are now only have one user, it's kind of you can imagine how does it work. So now we have 3 more styles, 3 more layers. These are vector layers in this case, and also the thumbnail generation didn't work. Let's have a look here. This is administrative boundaries on the 3rd level. In Bangladesh, those are called upazillas. And we have a nice style, but that style doesn't look right. So let's have a look at the vector styles, because administrative boundaries should be really only boundaries. So let's edit the style. So we can edit it. Now we get, once again, only XML. Okay. Then we create a new style. Let's go back. Rules and edit the style. And creating a new style, we can have some kind of presets we can choose. We can choose a border style and customize it after that. Save it as a border name. So this is kind of small. So we have a stroke color, so the outline. Let's choose something visible like red. And we can also, of course, change the density or the stroke width. We can also select classification styles where we can assign different colors based on the feature ID. For example, here we have it doesn't make sense, of course, but all this is supported by this style editor. Let's just use a simple style. So let's make it red and save it. And we can also make it the default style. So now the old style is obsolete, and we can create a map from all these layers. So maps are a second feature where we can use different layers that we uploaded to our instance and create views on this data from different layers. This is called a map here. And until now, we don't have any maps, so we create the first one, and then we can add data to this map. We can group data. For example, we have now the group administrative boundaries, and to this group we want to add some data, namely our administrative boundaries. So we just click on the plus, and it's in the map. No, this was wrong. The anomalies shouldn't be there. Oh. This one. Now we have 3 levels of administrative boundaries in the map. Of course, let's get rid of the Fazilas. This one. Yeah, well, you can, of course, change the visibility, change the order, change everything we want. We want also add the raster layer for this. This one. It's easier if you have thumbnails, to be honest. So this should be on the bottom. And now we can see for example, the temperature anomaly in a specific, a district. At this in this case, it's 2.2 degrees, for example. We can also create widgets or diagrams for specific layers. Let's see, this is divisions, districts. Where's the upper? This one is upper. Let's create one for this. Let's create a simple chart, a bar chart, and see how many upper zillas are in a district, for example. So let's wait a second. You can just click it together. So we are just saying that our x-axis is the district name. Our y-axis is the count of the different upper zilla codes, and we can add it to the map and give it a title. For example, upper zilla per district. And after that, it's kind of small. You have these widgets with diagrams in it or with text in it that help the user to understand what you want to say with this map. This is just an example that I know it doesn't make really sense. But after all, now we have a little map and we want to save it under a name. So this is, let's just call it Bangladesh. And now everybody can have a look at this map. You can also find it here through this Explore Maps button, again, without a thumbnail. But with a preview, you see which layers are used, and so on and so on. You can also assign permissions to who is able to see this map. For example, you can also create a map with data that is nobody able to see, but only in this specific map. And this is also described with metadata. So you can also assign the same metadata you had for your layers, also for this composite data set. So of course the user won't be able to see all these controls. There is some kind of preview button, I think. Well, I'm already in the preview. No, it's okay. So these are maps. We also can edit layer data. So for example, these upazillas if you have the rights for that, you have these editing tools again and can edit data. This is only possible for vector data. And then you have this feature table where you can edit selected columns or add data. You can also filter on something like that. For example, we want only this one. We want only opazillas from the district of Wola, I think, and only show these. So, for example, if you, where was it? You only get a subset of this. You can also download this subset, for example, as GeoJSON. Download filter data set. What's behind this one? So this is run asynchronously in a WPS job, and you can now access this data. As GeoJSON. So you can really create subsets and download them. And of course, you have the same possibilities here to create widgets and so on. Now we want to have a look at what apps are. We have here these. GeoNode does know different kind of apps. You can extend GeoNode with your own apps, but it comes originally only with a single one, namely GeoStory, which are a kind of, I don't know if you know ArcGIS story maps yet.
Just a quick question. So you show the layers that you imported in the data. So there is kind of API to do it like programmatically. If you have like a list of layers in the database and you want to automate all the
no, not directly. GeoNode has an API where we can retrieve data and so on, but it's not really capable of upload data through the API. What you can do is upload it to GeoServer. GeoServer has a configuration API, and then let GeoNode harvest all layers from GeoServer and create layers for that. That is possible. But it's planned to extend the functionalities of the API and offer these possibilities because everybody wants it.
And if you have this, for example, from the GeoServer, you can select a few layers, or it's like a complete mirror of what you have in the GeoServer you will have here.
You can do both. So you can harvest all, or you can create filters on the layer name. GeoStories are editorial content mixed with maps. So we have here kind of messed up user interface, in my opinion, but you can create elements. For example, here a title. Let's choose Bangladesh again. Then you can add different elements. For example, now a paragraph. Okay, maybe it's too small. Can add text for this and add more elements and so on. Oh, was it a footer? Paragraph section there. Yeah, you can add different sections where you can add text and so on. But most importantly, you can add media. So, for example, images, videos, and maps. For example, we can add our GeoNode map here. Where's the text? The text is on the very top button, but the user interface is kind of complicated because you have 4+ buttons. You don't see the difference. So there are no gray boxes like in the presentation before. This is just plain white, and you don't really know where the plus is anchored to. You can really describe in different steps and add layers in each step. For example, you have this table of contents, so to say, where you can add data or add content to. You can upload images or videos to GeoNode and reference them here. And after that, you can save it. Just again. So we have now yeah, an app. So it's also listed now here. No image at all. No image at all. It really doesn't work today. And you can then present this story to externals. I have always this editing view because I'm the author of that. But yeah, in the end, it will look like this. We can have a look at some instances that are not from us, where we can see this geo stories in use, where really content was added in a later part. Okay, that was the functionality about that. Of course, we can have users. For example, here we have 5 example users that are always added by our configuration right now. You can have groups where you can group these users. Well, in this case, we have only registered member, but we can also create, of course, a new group and give them some title. And decide who can join it and so on. So it needs a description. Just create a new group, and then you can assign members to this group. And in the layers, you can then, for example, here you can give access to these to this layer to specific people. Changing the layer permission, you can, for example, now select some group, and some group is then able to download this data. Download data is the next topic. One big button here. You can, of course, download the data as images, but you can also directly download the underlying data in different formats. You can also filter them and download just subsets of the data. And these are all operations that are not from GeoNode, but from GeoServer. If you see the link on the bottom, you see what it really does. So GeoServer implements a lot of OGC web services. In this case, it's accessing the WFS. It's a web feature service, a service to interoperably access vector data, or not really vector data, feature data, which in most cases has coordinates, vector coordinates, and just says it would like to have it at the output format JSON. I can't hover it right now. And this will redirect just to the server. If you have, here you have the URL, and just say, given me as GeoJSON. The same is for example, I can download this as a shape file, or as a CSV file, where it just automatically transformed to some kind of format. Of course, you that's for the WFs. For vector data, we are using the WFS. For raster data like this one, we are using WMS. So this is served by a WMS, and if we want to download it here, also we can download these images, but we can also download it as an ASCII file format that I never understood and never used, and you can download it as GeoTIFF. Oh, is anybody able to open that? Well, Eye of GNOME is not compatible with GeoTIFF, but you can download this as the formats. This is actually based on the WCS. You see, copy link. On another service, an OGC service, in this case, the WCS, the web coverage service, which is a way to retrieve coverage data or raster data or multidimensional coverage data. It's basically the raster version of the WFS, so to say. And here also we're just saying, just give us as a GeoTIFF. This too many tabs. This metadata that we can retrieve is working the same way in some download metadata is. For example, if we are clicking here on ISO, we are actually accessing the PyCSW that is embedded. So a catalog service for the web. It's named like that because else there would be a name clash with the coverage service. Where we just get a record by ID. So we are having an interoperable service that is widely adopted on how to encode the metadata and how to access the metadata. And this is what we want to do next. We want to use discover data and use the data from example Python. For this, we just want to give some layers a little bit metadata more. So let's just select this one, edit the metadata. Let's just again say this is Bangladesh, not global, and some free text words. So these are districts, and what did I use in my client code? I'm using, just districts is enough. And then we can save it, and it will be in the metadata response of the CSW. And now we can just have a look at how to access this programmatically. For this is really big. For this, I created a little Python script, and we are not using anything GeoNode specific. We are just using openly defined standardized services. In this case, the CSW, the WFS, and the WCS that GeoNode offers us. And we're using this OWSLib for communicating with the services. OWSLib is a set of tools to interact with OGC web services, and supports most of these services actually, and definitely supports what we want to do now. It's working like this. So the catalog service for the web is a Python instance object, Python object, and it has methods that are called on this object. But in the background, we are calling a web service, and during remote procedure call on the catalog. In this case, we would just want to we were executing the get records method, which is kind of the search mechanism of this CSW. And after that, we also wanted details of the specific record that we have found. So in this first step, we are just retrieving summaries. And after that, we are retrieving the full metadata of each of these records. Of course, we can limit it. So in this case, we want just a single response back, and not 10 layers, but only one layer. So some utility methods. And then we want to find how to access the data inside the metadata response. If we have a look at this response, with the download metadata ISO, we see a lot of noise in here. It's really, really long. No, I don't care about the context. I want to see this one. So this ISO metadata includes distribution infos, which is kind of an encoding how to access the data, actual data. And there are multiple ways to access the data. So GeoNode also links, for example, its own download links, where we can download the file as a zip file, for example, and so on. But it also offers us an interoperable way, namely, so it lists every format it supports. It's kind of tedious. Here. Here we have an online resource which is linking to the Geo server and says this is an OGC WMS. And here we have an online resource where we have also the same server, but it says we have an OGC WFS. And this is something we can work with. This is something OWSLib understands. And this is something we are searching for. And basically, this is a method to just find this online resource. And then we can download it. So our complete script is basically this. We want to plot it afterwards. We want to find a single record that is fulfilling some requirements that we have. For once, we want to have the one data set that has the title like this, the anomalies ensemble, temperature max, etc. And we want to, and then we want to download it, and we want to find a vector data set. In this case, a layer that is tagged with two keywords. In this case, districts and Bangladesh. I'm using CSW AnyText, which is kind of searching every field in the metadata description for this occurrences of these strings, just because there's some kind of interoperability problem between OWSLib and GeoNode. This is a typical case for interoperable services. It's only interoperable if it works, and it doesn't work. So we are using CSW AnyText instead of keyword or API, so subject or something like that. So we're just searching everywhere, but maybe the bug is fixed in version 4.0. I'm actually not sure if it's OWSLib that's not working or GeoNode. But after that, we want to download it and plot it. So how do we download it? We first find the URL of the service we are using. For example, here in the raster, we are searching for this reference that is named OGC WCS. In the metadata record, we also have the record name, the layer name that we can use. That is this record alternative. This is a name we can give GeoServer to give us this back. And then we are constructing a web coverage services and just calling this defined standardized method on this web service, where we will just say we want this record or this layer as a geotip. And after that, we process it with what was it called? Rio X-array to read it, standard Python library. For vector, it's quite similar. We are just searching for a different service or different protocol. In this case, WFS, Web Feature Service, constructing the service and calling this standardized method again with a title or with a layer name, and we want it as a GeoJSON, and we can read that with GeoPandas. And it should now work. Afterwards, we just add it to the same plot and lay it over. Laid over each other. So let's see. So we have really minimal libraries that we are using. We are using OWSLib, GeoPandas for the GeoJSON stuff, Rio X-array for the raster, and we are plotting this with matplotlib. And in theory, we should now. Of course not. Did I assign the right metadata? Maybe because I typed Bangladesh in uppercase. Oh, okay. In theory, it searches the CSW and finds this data set, and the raster data set, and downloads it through these standardized services and displays it. I'm not quite sure this is an exception or an error message from the. This should be from the CSW. It did work yesterday. That's all I can say. Sorry for that. But it finds the data by searching a standardized data format, namely this ISO metadata, searching in there for keywords that we want to have, and retrieves these through standardized services that are well defined, and uses just standard Python libraries to do that. We're not using some specific client code for GeoNode or for GeoServer or something like that. We are just using the open and standardized service interfaces. Yes, that's, I think, for the CSW. Another supported is also a document upload, which is really simple. You uploaded a file. These are the supported file types. You can extend that. It's a whitelist, so to say. You can extend that whitelist, and you can just upload the file. For example, let's just select some zip file here. Give it a title. You can also link to external resources. You can link documents to geospatial data. For example, we are saying this is related to this anomalies layer, and upload it. And it also has, we can download it, of course, but it also has the same kind of metadata everything else has. Another really good thing are these remote services. These are there to link external data services to GeoNode, and from out of the box supported are a WMS, so web map service, not a web coverage service, only the web map service. GeoNode is supported. You may think that this is also copying metadata or something like that from the other GeoNode instance. It does not. It just fetches data from the underlying web map service. Also, ArcGIS map server are supported, and this is an addition from us. The OGC Sense of Things API is also supported, which is a OGC service or REST service or REST API for observational data. You can have a look how that looks like. I have some examples. For example, let's start with a WMS. We just putting in this URL for this, and of course selecting the WMS. And now it's fetching, all layers or all data, not all data, but all layers that are present in this web map service. And after that, we can, for once we can describe this web map service, we can give metadata to it, but we can also kind of import layers from this web map service. It doesn't copy the data in there, but only the metadata, the data is referenced, and it only creates data sets for the metadata. In this case, we have some data from what's called from the Land NRW, North Rhine-Westphalia, and we just taking this one. We can import that, and it did work, and then it is visible in these layers. So we have where is it? What's the group? We have raster layer, vector layer, and now we have remote layers. It's displayed, it's fetched from the WMS at the Land NRW, and we can just add metadata to this data set. So if you have an existing WMS, you can just describe it more richly with GeoNode. The same can be done with GeoNode, and let's just use the ArcGIS server. Remote services, and this is an ArcGIS REST map server. And here we have a digital elevation model, and can import that. No preview. It's kind of strange because this one has a preview. And here we have, the digital elevation model in, I don't know, where is it? In the Wupper region, is it? It's just imported. You can add metadata for this layer to make it more findable. Now we have the GeoNode. This is an instance we have a look at later also. We can add it also here. Remote services. And this is a GeoNode web map service, so we don't have giving out the service URL of this web map service, but the GeoNode URL, and it will find out where is the underlying geo server for this instance. because it knows how a GeoNode is structured. This one has a lot of layers, I think. So it may take a little bit. Come on.
I'm not so familiar what exactly are the specifications of a web map service, but if this build to be built our own, say, QB server as well, or OSM data, which we modify and attach them as service.
Yes, that's possible, yeah. That's what we did for the Sense of Things API, which wasn't supported, and we just created support for that harvests the data from the API and inserted here as metadata. And yeah, now we have a lot of resources, 300 of them. Well, it's the same. Let's just click here, and it's working.
And is there any license or requirements? Any requirements on the data can be this description?
On the so
if we register the service,
yeah, sure.
Service, and that means we have to say access, like set them part of the metadata or
yeah, it depends on the service. So your web map service can state, please don't redistribute the data or something like that. I don't know if this counts as redistribution if you make it, index it in a search index. But of course you can state this data should only be accessed by these people. You can describe that, or you can enforce it with the user management.
Yeah, I mean there are many open data licenses, so we would just put that this data published under different open data license.
Yeah, you can do that. Yeah. So this license dropdown is customizable. You can add licenses like whatever you want. So I think he did it. I have no idea what this layer does, to be honest. And this is a problem. I've had a GeoNode instance. This layer has probably really rich metadata in the original instance, but here, unfortunately not. It doesn't copy the metadata. So this is just nothing. Last but not least, an extension we did for some projects. We are adding a Sense of Things API. This is a REST service, in this case, a Frost server, where we have, data streams of observational data. Let's just add it also. Things API. Should have not that much data in it. So in this case, we have time series. For example, here we have a station. This is of the University of Manitoba. We have a station somewhere in Canada that measures temperature. And we can also import this one. This is also in the layers now. No, it's not. There it is. The visualization does not yet work, but that's also planned to do that so that we can see some kind of diagram, for example, on the location in the map, what's the time series look like. But we have way more metadata that is harvested from this instance. For example, we have keywords that are extracted from the Sense of Things API. We see which sensor did record this data. And these are specifics for the Sensor Things API, which thing it was, which observed property. And we have also a direct link to the source of this data. So if we go there, we get directly to the data service in the background. It also doesn't import data, but only, fetches metadata, but at least a little bit more than the GeoNode remote service. These are remote services. I think that's it for these. Of course, you have a lot of management stuff. You can directly maintain the geo server. So there's a geo server underneath, and of course you can configure whatever you want here. Here we can see we have a workspace, one workspace. We have two stores. It stores the vector data all in the same PostgreSQL database, while the GeoTIFF or raster data is stored in the file system. So if you have a look here, it's somehow stored in a temp folder actually that is referenced here, while the other one uses the embedded Postgres database. And of course, you can configure whatever you want. You can configure your own image mosaics, for example, in GeoServer and harvest it from GeoNode. And of course, it's a Django app. I'm not sure if you're familiar with Django, but Django has these admin interfaces where you can really have, can basically manipulate the database directly. For example, all these layers we have are also listed here with a lot of fields where you can edit data or mass add data, so to say. You can also manage, where is it? Manage keywords, for example. Oh, and there are many keywords now through the SDA import. But you can create really hierarchical keyword structures that can then be used later. For example, if we add a new keyword, let's call it observed property. Observed property. It says that we can structure our other properties, for example, these two, and put them underneath these. And this is really usable to find data in the view, so in the UI, because now we have here in this keywords array, they are structured like this, and we can filter. Just give me the one with air temperature. Exactly. So let's get back to the presentation. We can extend GeoNode really extensively. We will have a look at two examples. One is not really, you won't think that it's GeoNode. You can easily change styles, create a custom theme, switch out background images, logos, edit the menu, add new menus, items, and so on. That can all be done through the user interface, through the admin user interface. But more importantly, we can extend all this Django application with additional Django apps. For example, this sensors. Yes.
One question. So when you're talking about extending it, is it also possible to extend the metadata scheme?
Yes, also.
So complaining about the data quality.
Yeah.
So could I, in theory, if I have a good idea, could I then also change the metadata?
You can change how GeoNode stores it, but to change the metadata response, you would have to change the ISO schema. You can, of course, extend the ISO schema or create new keywords or new thesauri for managing these. Basically, you have to extend then ISO. That's less of a problem for GeoNode, but more based on your willingness to create XML schema. Exactly, you can create Django apps. For example, this Sensor Things integration is just an app that is plugged in, so you can disable it, enable it, plug it in another GeoNode instance. You can create new APIs, pages, whatever, new types of objects. For example, here these new external service types are done through through apps. For one, the Send the Things API, and we also created one for an WCS, which is a kind of experimental phase. So we integrated the metadata fetching of Rasterman. So these can be done through through Django apps. But you can do a lot of more. You can basically change every template you find in GeoNode. Let's have a look at some existing instances on the web. This is the portal I've fetched the data from. This is the Climate Change Information Knowledge Management platform from Bangladesh, where we have a lot of content that was integrated in this instance, and you have a completely different menu than before. You have really basically all kind of content here, and if you have a detailed look, you can still find, for example, here this layer view. In this case, we have I think over 2,000 layers. An example for what you can build with the GeoNode is, for example, this climate impact atlas we have here, which uses data from GeoNode and fetches data based on their keywords, how they are tagged with which keywords. For example, here we have this data I showed before. It's actually fetching 2,000 layers, so it takes a while. Come on. So you can easily select the data you want to see, and in the background, this is just communicating with the GeoNode API, and no layer is hard-coded in this application. And of course, you can easily create custom dashboards, custom apps based on these GeoNode APIs. Another example is this one. Another example would be this. This is a GeoNode instance of the Thünen Institute, which is what does it do? It's a research institute in Germany for, I think, agricultural data. For agriculture, and it created multiple atlases, how they call it, where you can explore data. And they are actually created, so to say, a new app, not GeoStories, but here they're called atlases. They created some maps and some data sets, and these are looking way better than mine. So we have 4 maps, for example, here, where we can see another feature of GeoNode. Here we have a map that has time enabled. And it's really fast. Here we have a widget which gives us some kind of tutorial. This is just a standard GeoNode feature. Let's get rid of it. And here we have data sets of, I think, fishes that are found. So we have, I don't know the English names for all these fishes. Sorry about that. But we can visualize this data, and we can also skip to time between the years, so we can go back in time and see how it has been developed. And of course, we can select. These are all kinds of fishes, so to say, but we can also select only a specific type of fish. Also, we have these atlases, which are kind of GeoStories. So we have editorial content, informations, and then we have these 4 atlases, I think. Let's have a look at this one. And in these atlases, they stuffed in some kind of maps or some layers that can be thematically grouped together. So this is all stuff about the ocean, about fisheries, and they are aggregating these in these atlases, which is a new type they developed and just implemented in GeoNode. Of course, you can also here access data. We have here these vector temporal series. Oh, well, let's quickly change. Oh, it's got in English. Okay. Vector temporal series, where we can see this layer. This layer is also temporal enabled, so we can. It's really moving a little bit. We can go through this time window, and we can also see this in the metadata. Data where we have a temporal extent, I hope. No, we don't have a temporal extent. But you can encode a temporal extent besides where it is.
Other cloud OpenGeoHub. Can you add a cloud OpenGeoHub, but how did you drop the file that you just?
No, you can actually not. That's what now will follow in my conclusion. In summary, so what aspects of research data infrastructure does GeoNode offer? We definitely have really the aspects of findable, accessible, and interoperable really covered through the OGC services, through the standardized metadata, and so on. There are some kind of problems with this quality statements, I think, but this is a common problem for all ISO metadata standards, for all data sets that are described with ISO metadata. But there's still, in my view, some things that are missing. GeoNode focuses really on this viewing services, so map server, WMS, and so on. But we also have a lot of OGC data services. For example, the SOS, Sensor Observation Service, which stores sensor data. The SDA, okay, we are working on that, and also on the WCS, but it's not supported out of the box. And these are the services that we actually using to access data. Nobody uses a WMS to access data. And also the OGC APIs, the new generation of web services, are not yet supported. On the one hand, it's not supported to import them. It's not supported to, for example, take an OGC API features and integrate it in GeoNode, but it also doesn't offer these kind of services. So you cannot access the data as an OGC API features. And the next point is what you just mentioned. All data is stored locally. Of course, you can push the Postgres database to a cloud setup and let it use a software as a service Postgres database or something like that. But it's not able to store geotiffs, for example, in S3 and access it as cloud optimized geotiffs. It can be done because GeoServer supports it. You can upload geotiffs to S3 and just integrate it in GeoServer. You have to do it on your own, and then afterwards you can harvest it from GeoNode. But all this upload mechanism doesn't work currently with cloud infrastructures. But there are rumors that this will be better in version 4, but I didn't try it out yet because they abstracted away a little bit this data storage mechanism they are currently using right now. It's just file system. And it should be you should be able to swap out what kind of storage you are using, but I'm pretty sure that that's not yet ready, and you won't be able to just plug in, here's my S3 bucket, just use it, upload geotiffs to there. Exactly, and in my opinion, the federated approach is a really nice idea. I mean, one of the problems of research data is that it's all decentralized, and this federation approach could really help. So some research institutes setting up a GeoNode instance, and some organization a level higher up or something like that is just harvesting these different GeoNode instances. So we have a decentralized approach, but still a centralized search or something like that. But because GeoNode does not copy the metadata or doesn't redirect the metadata if you harvested it, it's not yet usable for this.
So the official release is now 4.00.
Yeah, actually 4.0.0 Mark II or something like that. Yeah.
And does it includes now the WCS, for example? Can you do like GeoNode translate or
no?
Because I mean the Geo server has it. So
yeah, the only problem is that if you upload data to GeoNode, it will somehow magically process it and tries to configure GeoServer, but GeoNode doesn't support everything that GeoServer supports.
But when you install the GeoNode, you also get the GeoServer URL, so you could just go to GeoServer and access the WCS, no?
Yeah. This support for WCS that is missing is WCS as a remote service, as a service you have not control over. So, for example, if you have an old map server or something like that running around that has a lot of coverages, you cannot integrate it. But maybe come again.
Not supported.
You can open GeoTip, of course.
But how is it so that I don't upload it there and just
you cannot just give it an URL. That's not possible. So you can configure it manually in GeoServer and then let GeoNode just harvest it from the GeoServer. Just will find it then there. But you cannot use the user interface to say here's a bucket, please fetch all geotips from there and configure them or something like that. Any other questions?
What's the biggest change in GeoNode from the last GeoNode? What is the biggest improvements?
Well, I'm not a GeoNode developer. I'm not 100% sure, but the main big topics were this change in the storage solutions, that you can plug in a different storage driver, so to say, instead of the file system. And besides that, they tried to separate the UI from the Django application. So they are going in the direction that they have really an API that they use just from a single page web application. Right now we have a classical user interface where we have page reloads and so on, and they are not using really APIs, but more HTTP post calls with form content or something like that. And they're trying to go in the API and web application direction. But I'm not sure if they are completed because the API still isn't really a writable API, but only readable.
And can you tell something about alternatives to GeoNode? There are some alternatives, right?
Are there?
Out of box, because there's the QGIS server and QGIS client.
Yeah, I personally didn't use QGIS server yet, so I'm not familiar with the feature set and can, to be honest, not compare them. There's GeoNetwork, which is kind of similar, but doesn't host the data, I think, but only manages metadata. It's a catalog, so to say. And that's it, basically, I think. But I have to look at QGIS server.
Okay.
Yes?
For this maps you showed before, these little map apps, is it possible to integrate a function where you can choose from pixels or like a group of pixels by mouse click and then get the mean or something?
I'm pretty sure that GeoNode doesn't offer this out of the box. So at least not this processing, I think. There are some functionalities that I'm never used, to be honest, and there is this spyglass, but it does something different. So we have also, for example, such a swipe feature where we can do something like this, but no, it doesn't support that. Of course, you can, create your own add functionality to this. This is just an open source component that you can integrate. You can extend that. This is a React app and add this functionality because GeoServer does support it.
Yeah.
So in GeoServer, you can just run a WPS process. I think it's zonal statistics or something like that, and do it this way. But it's not out of the box. Anyone else?
It's hard.
Okay.
Did you?